Hello everyone and welcome to the Matlax, Mathematics Made Simpler. And in this video, we'll be looking at coordinate geometry, that is straight lines 2. We've already looked at straight lines 1 in the first video, so you can also check that one out. The link will be in the description. So let's look at this. Now this lesson will focus on the aspect of collinear points. We'll also look at equation of a straight line, then we'll move on to parallel lines, then we'll finally end at perpendicular lines. So let's begin. Collinear points. Now 3 points are said to be collinear if they lie on the same straight line which has a constant gradient. So if the gradient between any pair of the points are equal, the points are collinear. Let's see a worked example here. Now the points 1a, 3, 2, and 4a minus 1 are collinear. We are to find the possible values of a. Let's see. Now we know that gradient is equal to y2 minus y1 all on x2 minus x1. I denote the gradient between this point and this point as m1 and that between this point and this point as m2. So then we know that m1 will be 2 minus a all on 3 minus 1 and m2 will be 2 minus 1 all on 3 minus 4e. But since the points are collinear, they have a constant gradient, so we can equate m1 and m2. Then we get that 2 minus a on 2 should be equal to 3 on 3 minus 4a. Then we can simplify everything and arrive that 4a squared minus 11a should be equal to 0. Then the values of a will be 0 or 11 over 4. Let's look at this question, which says that the points minus 2t, t minus 2t plus 6, and t plus 2, 3t plus 4 are collinear. We have to find the possible values of t. This is a similar question to the one we solved earlier, so we will use a similar approach. So let's see. We know that gradient is equal to y2 minus y1 all on x2 minus x1. Gradient m1 is the gradient between this point and this point, and m2 is the gradient between this point and this point. Then because the gradients are equal, we can equate them. So we get that, we can simplify everything and get that t squared minus t minus 12 should give us 0. Now the possible values of t are minus 3 or 4. Let's move on to equation of a straight line. Now the general form of the equation of a straight line is given by ax plus by plus c to be equal to 0, where a is not equal to 0. Now the slope equation is of the form y to be equal to mx plus c, where m is the gradient and c is the intercept on the y-axis, meaning where the line crosses the y-axis. So now let's see. There are two ways to find the gradient of a line. Now we'll look at the first one, which is finding the equation of a line given the gradient and the point on the line. Now the equation of a line through the points x1, y1 with gradient m is given by y minus y1 to be equal to m into bracket x minus x1 with our brackets closed. So now let's see a worked example. Now a straight line has gradient 3 on 2 and passes through the points 1 minus 3. We have to find this equation and intercept on the y-axis. So then we state what you are given in the question, then we state our formula for it, then we substitute values into our formula, then we arrive that 2y minus 3x plus 9 should be equal to 0. Now this is the general form. Now making y the subject, we get the slope form, which will simplify it so that we can easily determine the y-intercept, which is minus 9 on 2. Let's move on to the second way of finding the equation of a line. Now you can also give this question a try. That we see is saying that a straight line has gradient minus half and passes through the point minus 5 minus 2. We have to find this equation and intercept on the y-axis. So it takes the same structure as this. Let's move on to the other way of finding the equation of a straight line. Now we have to find the equation of a straight line given 2 points on the line. Now to find the equation of a straight line given 2 points on the line, we first find the gradient of the line, then we apply the formula. That we learned earlier. That is finding the equation of a line given the gradient and the points on the line. Now any of the points can be chosen, we will still arrive at the same answer. Let's look at the work example. Now we have to find the equation of the line AB, which passes through the points 2, 4 and 5, 6. So we know that we have to first determine our gradient, which is 2 on 3. Then we state our formula y minus y1 to be equal to m into brackets x minus x1. Then we substitute into our formula, then we arrive at 3y minus 2x minus 8 should be equal to 0. Now this is a general form. We can also make y the subject, which will get the slope form. Then we can easily determine the y-intercept if it is asked, which in this question is 8 on 3. Now let's look at parallel lines. Looking at this diagram, now these two lines are parallel. They make the same angle with the with this direction, with the horizontal. So parallel lines will subtend the same angle at the horizontal. Now, because we've already looked at gradients in part 1 of this video, and we related the gradient to the angle made by a line on the horizontal, and we said that the tan of the angle is the same as the gradient. So then if parallel lines have the same angle, they make the same angle at the horizontal, then they will also have the same gradient. Now we have to find the equation of a line which passes through the point 2, 3 and runs parallel to the line 2y minus x to be equal to 3. Let's see. Now we represent this in the slope form so that we can easily determine the gradient. Then we know that the gradient is half. Now because parallel lines have the same gradient, then the gradient of the line which runs parallel to this line is also half. Then we use our formula for finding the equation of a line. When we are given a point and a gradient, we substitute values in it, and we know that the equation of the line is 2y minus x minus 4 to be equal to 0. We can also make y the subject to determine the slope form also. Now let's look at perpendicular lines. Now two lines are said to be perpendicular if the product of their gradient is -1. So it follows that if the gradient of one line is m, then the gradient of the other is the negative reciprocal, that is -1 on m. Let's look at a worked example here. Now we have to find the equation of the line perpendicular to 2y plus 3x to be equal to 6 through the point 5, 2. So then we represent it in the slope form. This line, we represent its equation in the slope form so that you can easily determine the gradients. Now because the gradient is perpendicular, the other line that we are finding this equation is perpendicular to this line, we find the negative reciprocal of this one, that is -3 on 2, and that will be the gradient of the equation of the line we are finding. So then we know that the gradient of the perpendicular line will be 2 on 3. Then we have our gradient, we have a point on the line. Then we substitute values into our general formula, y minus y1 to be equal to m into bracket x minus x1. Then we arrived at the equation of the line that is perpendicular to the line 2y plus 3x to be equal to 6 is 3y minus 2x plus 4 to be equal to 0. We can make y the subject here so that we determine the slope form of this equation. And I think that's all for this video. Now these are some trial questions for you, and don't forget that this is the MathLax. Leave a like and also subscribe to the channel.